Last talk before the lunch, that is by Dr. Rizwan Raza. He's an associate professor at COMSATS University, Lahore. His PhD in energy technology with specialization in fuel cell from Royal Institute of Technology, KTH, Sweden. He has 16 years of experience in energy research and teaching. He has published over 200 papers, delivered 60 invited talks, and 30 different conference papers with an impact factor of 1,000 and H index of 38, number of citations 4,500, and edited 2 books, 10 book chapters. So please welcome Dr. Rizwan Raza.
Bismillahirrahmanirrahim. Assalamu alaikum. Thank you very much, Dr. Adnan, for inviting me. And I would like to thank also the conference organizer, Professor Ilyas, to discuss about my research area and about some of my research results. I will try to give overview what we have done and what we are doing. So, as you know, as per my title of my talk, I will discuss today about the climate change and what are the major challenges nowadays in the world, especially, from last many years, there are many issues in the world they are discussing. I always discuss about one of the Nobel laureate quotation. He discussed about the next 50 years top 10 problem, and energy and environment are the top one. But nowadays, environment and climate change, of course, is correlated each other. And actually, the one of the major challenges is the climate change. What we are affecting here in Pakistan as well, but all over the world we are affecting. So how it can be, overcome, or how it can be addressed with the, like is the theme of the topic about the smart materials. How can we play with the smart materials to address these issues, particular climate change and energy crisis? These are the two major challenges nowadays. So in my talk, I will try to cover these things. Especially I would like to thank Sir Khurshid, who discussed about the emerging technologies, smart materials, actually which make more easy to discuss about my topic today. So I will try to cover some more things, especially about two emerging technologies. One thing is about fuel cell, which is also called the clean energy technology. Another thing is chemical looping system. Actually, nowadays, after the, if I talk about the last 100 years, after industry revolution, with the burning of fossil fuels, how much emission is there in carbon dioxide particular, and due to this, how much it affecting on the climate. So how it can be covered? Of course, there are many technologies. People are working in a different way, and one of the new technology which has been, I can say, is discovered in last 15 years from the one of the Swedish Professor Anders. Actually, recently I have completed one project with them in Chalmers University regarding this one. And he said we can control these carbon dioxide emission. In particular is a chemical looping combustion system and chemical looping gasification, actually two different technologies. So let's see. As I, based on my background on energy materials, so that's why I will discuss about some smart materials as well. So here you can see, one of the our requirement nowadays in Europe also, before it was not like before COVID energy crisis, but there are now also some energy crises are there. And energy and environment is also correlated each other. If you are getting energy from conventional system, from fossil fuels, then there is emission. And based on emission, you are going to pollute your environment as well. So first we have to address this existing system, our existing industry system, how there is lot of emission, how it can be controlled, and what are new technologies, either there is some emissions, so how it can be controlled, and then in parallel, some emerging technologies like renewable energy based, in particular fuel cell, which is also called the future technology. So first, on existing system, based on the burning of fossil fuels, there is a lot of emission, and we have to control and we have to capture those technologies, those things from this burning. You can see from this graph, in last 100 years, as I mentioned, from this to this till now, how much is emission is there, and almost 1 to 1.5 degrees increase globally. Our Earth is, due to this global warming, the temperature is increased 1 to 1.5 is a different data is quoted. And one of the climate expert recently predicted that same temperature we are going to achieve in next 10 years. I mean, you can compare, in last 100 years, we achieved, in negative sense, 1 to 1.5 degree. And next 10 years, again it will increase from 1 to 1.5 degree. So how? Why? Because of this emission. So first we have to discuss about this our existing system, our existing power technologies, our existing power industry and other industry where is a lot of emission. So based on that, very famous conference in 2015 regarding the Paris Agreement, which is more famous regarding the Paris Agreement, where European Commission have discussed and they have agreed upon to give a new VN. Unfortunately, in Pakistan, we are not thinking about these things. A lot of senior professors are here. They know about things. But European Commission, they give this VN 2050, where they want to achieve 50%, in other words, is a CO2 emission reduction, 50%. But some countries, they have given their own VN, like Germany, France, and some Nordic countries like Sweden, Norway, Finland. They give, we should go for the negative emission. What is the called negative emission? Always emission is there. If emission is there, how it can be negative? So just for the students, negative emission like this way, from our industry or some other auto vehicles on the road or some other things from the conventional, the emission is there. What we are emitting and how much we are capturing, or what we are storing. So it means, if you are emitting 1,000 ton and you can capture 1,000 ton, it means there is a zero, like a simple equation. But if you are emitting 1,000 ton, but you are capturing more than 1,000, but how it is possible? If you are emitting 1,000 ton, how can it be capturing more than 1,000? Actually, the climate change and environment issue is not only for the one country, it is across the border. Emission can come from other side, like our emission can go to the neighboring countries, and neighboring countries can come some their emissions to our countries. So that's why they are thinking, from neighboring countries or neighboring area, if something is coming in the form of this emission, we have to capture also. So that's why they are thinking about the negative emission. So that's why here is some scaling of different countries, like Sweden. They achieved zero emission till 21. Last year they achieved zero emission. What they are emitting and what they are capturing. But now they have planned till 25. Before, in Paris Agreement, they presented they will achieve in 2030, but now they have planned and revised in their policy, they will go for the negative emission till 2025. So you can see here is Sweden, Germany, France, and many other countries, how much they have achieved till now today, but where we are. So anyhow, there are a lot of things where we can play with these technologies and we can address these issues like smart materials, nanomaterials, and many other. I'm not going to discuss question about madam, but is a debatable. A lot of things can be discussed. But in science also, like in poetry, शायरी, कुछ अच्छे वर्ड्स इस्तेमाल किए जाते हैं फैसिनेटिंग, तो साइंस में भी करने चाहिए ताकि स्टूडेंट्स अट्रैक्ट हों, पता चले कि उसकी वर्थ क्या है. अगर सादा लफ्ज़ों में बयान किया जाए तो शायद उसकी वो एप्लीकेशन वर्थ ना हो सके. Anyhow, I'm not going to discuss on those things, but lot of nanomaterials people are working in different areas, particular in energy technologies. Many technologies are there. Renewable energy based in renewable wind, solar, biomass, and there is other now is a storage, energy storage issue based on energy storage. There is supercapacitor batteries and some other technologies also there. So first thing is, as I mentioned, my talk is based on two parts. First thing is on existing technologies, I mean on existing industry system where we are getting emission is power industry. So chemical looping they have introduced. If we can integrate this system with our industry, we can capture CO2. 100% can be capturing. And this is a chemical looping can be defined like this way. Inherently, we can separate CO2 from this system. How? But I just can give you this some from this figure idea. I mean, if there is one air reactor, another is a fuel reactor. In fuel reactor, if you can introduce some oxygen carrier materials, because in fuel there you have a CH4, biogas, or some other gases, then there is emission of carbon monoxide, CO. But when you are using oxygen carrier materials, it can donate a oxygen and it can be CO2 and it can be easily separated from that system. So there is also some like in electrochemical devices, you know, the redox cycle, oxidation and reduction process, also in fuel cell and some other devices. So anyhow, based on this chemical looping, that professor also gave an idea how it can be implemented in industry, and they have already installed more than 100 projects in different industry, but they are planning till 2050 more than 3,000 projects for this one. In university, I mean, actually Shalmar University is almost, if I can say, more than 90% based on the industry funding. Unfortunately, we don't have here in Pakistan. So before, I just want to give my own opinion in industry and academia collaboration. Actually, काफ़ी डिस्कशन हुई, डॉक्टर अदनान साहब ने भी सर ने भी उसको एड्रेस किया. तो one of the thing, we always, academician, professor, teachers, researcher, they are trying to get some problems from the industry, but we could not get. As mentioned, many examples from senior professor. Actually, our industrialist is not willing to come. They want profit in a day, what they have invested. But thing is that we propose like this way. If our policy makers from our government side, they should implement some kind of instructions to the industrialists. They should send us some kind of coordinator or any responsible, or they should make, every industry should have a R&D section, and that R&D section should collaborate with the industry. Otherwise, that industry should not be like our EPO, Environmental Protection Authority, EPA. They have a, I mean, without the environmental certificate, we could not open any industry. But similar way, without any R&D section, industry could not can be work in Pakistan. So in this chemical looping system, what are the oxygen carrier materials, which are the main role? Nowadays, they are using the natural ores material. Natural ores, ilmenite, is a very common. Ilmenite is combination of iron, manganese, titanium, mostly these three components. Some ores like Egyptian-based, they are very common and more giving results in this chemical looping system. They are based on the iron titanium. Some Canadian ores, they have iron manganese base, but there are some impurities. But they have on how we can develop new materials of oxygen carrier. They have their own requirements. I'm not going in details. So, but of course, if oxygen carrier, then it should have a high oxygen carrier capacity. But they have a efficiency performance 1%, 2%. How it can be increased? So that's why my recent project was about this one, to develop synthetic ilmenite materials, which can work efficiently in this system. And we develop, here I have mentioned 4 different, but as I mentioned, there is in fuel, there is a methane, biogas or some. Also catalyst can work very efficiently there. If we can introduce, before in ilmenite there is no any catalyst, we also introduce some kind of catalyst and its efficiency increase. Not going in again XRD function, which we have developed different oxygen carrier to see what kind of phases are there, I mean iron based or titanium based. Actually titanium is using as a supporting, but main role is there of oxygen. Fe2O3, it can be reduced and oxidized, reduced and oxidized in air and fuel reactor. So main, the confirmatory, I can say the confirmatory test are the, how can we test this redox cycle for this material. Either it is stable or it can give you some more oxygen carrier capacity, how it can be calculated from the system. TG is a best tool. I mean, because air fuel reactor is working more than 800, 900 degree. So in this, we have used, here is a one material, which have 50-50% ratio of iron and titanium. Actually, titanium can stabilize also iron phase. So there is, first we have checked in the fuel syngas and other is in methane. And methane is very stable, but oxygen transfer capacity in syngas is very good, because in methane there is some carbon deposition on the material, and then there is some agglomeration during this process, and there are a lot of challenges, also problems, but it can be catalyzed with a different catalyst material. So then had been tested in different temperature, but you can see here is at 1000 degrees a very have a good redox cycle, and it can be seen from here the good oxygen transfer capacity. So anyhow, then we have tested in XPS which phases, mean Fe2O3 to F3O4 hematite to another phase, reduced phases, and it has been seen that it is also stable. So another, I am just skipping this, we have introduced molybdenum as a catalyst in this oxygen carrier, and further its oxygen transport capacity has been increased till 9%. And then recently we are trying to integrate to make some hybrid system with the fuel cell and this chemical looping system. Because in chemical looping system we can get also hydrogen gas after some reformation, if we are going for the reformation system or the gasification system. That hydrogen can be used in a fuel cell. So here is a mechanism how it can be donate oxygen vacancies from one part to another part. But I am going to discuss my second part, which I have more related to my PhD work as well, is the energy material. Why hydrogen energy is more important? As you know, hydrogen is a very, very clean fuel, and hydrogen is abundant in this universe. यानी हमारा जिंदगी का जो सिलसिला है इस कायनात का, वो पानी के साथ लिंक्ड है. पानी है, हम भी हैं, कायनात भी रहेगी. तो पानी H2O है. So we can get hydrogen always from there. But another thing is, I always say, the best utilization of renewable energy resources is the fuel cell technology. Why? Because in renewable energy resources, solar, they are dependent on some system. Wind, they are dependent also on some system. And one time it's have a good, another time it's not. But another time we can go for the storage system. But that storage can be in the form of hydrogen, and then that hydrogen can be integrated in the fuel cell system. So that's why it's the best utilization. So hydrogen energy, H2, hydrogen molecule, there is a one proton, one electron, and when it can be oxidized, there is a reduction process also. So if you can break the bond and you can get a proton, electron, and electron you need for your power system, for your electricity. So anyhow, another thing is the hydrogen have best fuel among other fuels. Why? It have higher energy density, 142 megajoule per kilogram. गाड़ी लाहौर से इस्लामाबाद आनी है, 1 किलोग्राम हाइड्रोजन इज एनफ, यानी उसकी हाई एनर्जी डेंसिटी है एज कम्पेयर टू ऑयल, पेट्रोल, डीजल एंड अदर थिंग. देयर इज नो एनी emission, zero emission. So anyhow, lot of question for students mean for any new technology, where, why, when, what, how can we get these. But just to give for students how it can work, it's like a battery, 3 components, anode, electrolyte, cathode. On anode side, we can give a fuel in the form of hydrogen, and on cathode side, we can give a oxygen, or we can give directly air, because in air we have oxygen. So on anode side, oxidation, cathode side, reduction process, and here is only, just want to mention, as I mentioned, there is a 3-phase boundary on the interfaces of electrolyte and anode. When there is a hydrogen and there is a chemical reaction, oxidation process, then electron can pass through the circuit and proton can pass through the membrane. Actually, membrane is based on the proton conductor. And based on this electrolyte, it have a different types, alkaline fuel cell, phosphoric, molten, and solid oxide. Our more work, and in our lab, we are working on solid oxide fuel cell. Solid oxide fuel cell, why? Fuel cell have high electrical efficiency as compared to other power generation system. But among the fuel cell, solid oxide fuel cell have higher efficiency, more than 60%. I am talking about the electrical efficiency. But it is the main challenge, it is working at very high temperature, more than 800, 900 degree. Right now, what we have this kind of product, in particular in USA, Bloom Energy is working on this one. But it's working on 800 and 900 degree, and there is a conventional electrolyte is YSZ, UTS stabilizer Konya. But problem is there, if we have a high temperature, there is also other accessories to assemble it and to make it more commercial. It's very expensive at very high temperature. So it's big challenge how to reduce its operating temperature. So for lowering operating temperature, when you lower its operating temperature, there are a lot of challenges again. There are a lot of losses, polarization losses. Among the polarization losses, mass concentration losses, ohmic losses, and activation losses. But ohmic losses are main important due to the materials, anode, electrolyte, and cathode. So those some conventional material have electrolyte, and electrolyte is a key component, and electrolyte should have a 0.1 Siemens per centimeter. But for this, to achieve this ionic conductivity, if we are going to reduce its operating temperature, we need some such materials which can work at very low temperature, and it can give you same ionic conductivity. So based on one of our project during my PhD with the European Commission with the different 5 countries, they agreed upon these 5 key points, how can be it reduced. Here one thing is about the interfacial material design. I'm not talking about the other things, but this interfacial design, based on that, we have designed one material coated with the existing electrolyte, doped ceria, with some carbonate material. There is some interface, and actually that interface can enhance the ionic conductivity. So just to cut another work from my PhD, she also developed, and here is a TM image where you can see where is an interface and where is a coated material, where is a core and core shell material, and how ion can pass through. We give the name highway for the ions, ion materials. So here is some impedance spectroscopy to check, and a lot of work have been published regarding this, but I want to mention this one. As I mentioned, among the many challenges, ohmic losses is the main challenge regarding the materials when you are going to lower its operating temperature. And also there is a anode, electrolyte, cathode. There is some compatibility issues. Some high temperature based material people knows about that. If there is a different thermal coefficient of different components, when you can combine it, then there can be, when it can be a one device, it can be a problem, because they have a different thermal coefficient, device can be crack, or so there are a lot of challenges in 3 component. Just they are thinking about simple 3 component, but why not it should be a single component? So based on one article from Israeli professor in 90s, mixed ionic and electronic conductor, we see some kind of properties. We got that. Based on that, we develop a material, but we optimize an ionic conductor and electronic conductor. And we develop one single layer fuel cell, and it can work like a single page. One side can act surface, can act as a anode, other side can act as a cathode, surface, but it is a single component. So just based on the surface reaction. So not anode separate, not cathode separate, not electrolyte separate. So mixture. So anyhow, it has a same working principle, same advantages. Even at high temperature, there are other beauty is you can use other hydrocarbon, biogas, methane, ethanol, methanol, I mean liquid based, solid based, gas based fuels, hydrocarbon fuel based you can use there. So based on that, we published a lot of advanced energy, nano energy, energy environment. Even we submitted to Nature Nanotechnology, they gave us a name. Why not? You can give it, it is a 3-in-1, I mean from 3 to 1. So after that, we can name it. Its working principle is here. Actually, it is a mixture of ionic and electronic conductor. Gray are the ionic conductor, red balls are the electronic conductors. So there is a nano redox reaction. Here you can think about the importance of the nano materials. I mean how it can work. I mean otherwise it was redox reaction on bulk material, but here there is a redox reaction on nano scale. I mean from particle to particle, from one ionic conductor to another electronic conductor. There is interface. In any, you can say lot of interfaces, but here you can find there is a redox process. So I'm not going detail. If somebody want to ask question, so can be discussed later on. So some work from our MS student, they have optimized and published a lot of, one of just based on another project on silicon carbide, and just to give you about some recycling. So as in Pakistan, I mean, we are working on different things. Madam discussing about one small plate, what will happen after our eating. It will affect on also our environment and things. So we have not really thinking about our environment and not thinking about our waste material. So in the countries, I mean Sweden country, more than 99% waste material they are using in the recycling way and for the productive way in a different applications. But unfortunately here is no. So एक छोटी सी अक्सर मैं टॉक्स में कह रहा हूँ कि हर बंदे के पास मोबाइल है, लैपटॉप है, हमारे उसके अंदर क्या है, लिथियम आयन बैटरी है. तो बैटरी ख़त्म हुई तो हमने क्या किया, फेंक दिया, या किसी शॉप कबाड़िए के पास किधर गए. लिथियम भी बहुत रेयर है यानी बैटरीज में, और लिथियम कहाँ पे कह लें कि ये आफ्टर 2025 कह रहे हैं कि आफ्टर 25 में भी लिथियम ना रहे, इलेक्ट्रिक व्हीकल्स तो आ रही हैं तो क्या बनेगा. तो वी हैव टू रिसाइकल. यानी पाकिस्तान के अंदर इतनी पॉपुलेशन है, इतने हम मोबाइल यूज़ कर रहे हैं, लैपटॉप यूज़ कर रहे हैं, तो उस वेस्ट को इतना पोटेंशियल है, इंडस्ट्रियलिस्ट को आना चाहिए, और ये इंडस्ट्रियलिस्ट को एकेडमिशियन रिसर्चर ही बताएंगे कैसे इसको रिसाइकल किया जाएगा. हमने एक छोटा प्रोजेक्ट किया और उस पर प्रोजेक्ट सबमिट भी करवाया है. यानी देखते हैं क्या फंडिंग होती है स्वीडन के साथ और आवर फंडिंग एजेंसीज़ के साथ. तो इसके अलावा हमारे यूपीएस की वेस्ट बैटरीज़ हैं, उस पर एक पीएचडी स्टूडेंट हमने यानी वो काम कर रहा है ऑलमोस्ट नियर टू कंप्लीशन विद द जीसी फैसलाबाद. और इसके अलावा भी यानी बहुत से वेस्ट मटेरियल हैं, एग्रीकल्चर वेस्ट है, उसको यूज़ किया जा सकता है. हमने छोटे ये एग शेल की छोटी सी एग्जांपल हमारे अंडर ग्रेड स्टूडेंट ने किया कि एग्स हम रोज़ाना अभी नाश्ता करके आए होंगे, आमलेट खाए होंगे, बहुत से यानी उसके शेल्स कहाँ गए, वेस्ट हो गए. इसी इलेक्ट्रोलाइट जो फ्यूल सेल के अंदर है, इलेक्ट्रोलाइट, उसके अंदर हम क्या यूज़ कर रहे थे, सीरियम, रेयर अर्थ इज़ वेरी एक्सपेंसिव. गैडोलिनियम को अडॉप्ट कर रहे हैं, समैरियम को अडॉप्ट कर रहे हैं. तो कैल्शियम कैन बी एक्सट्रैक्टेड फ्रॉम दिस एग शेल्स, और ये एग शेल्स से कह लें कि कैल्शियम जो हमने मार्केट से परचेज़ किया वो उससे 1/10 प्राइस में हमने उसको यानी अपनी लैब में बना लिया. यानी वो कह लें 1000 रुपये का, तो ये इस पे कास्ट ऑलमोस्ट कहने 100 रुपये आ गई होगी. तो यानी वेस्ट है, उससे हमने कैल्शियम कार्बोनेट, कैल्शियम ऑक्साइड एक्सट्रैक्ट किया, उसी को डॉप किया सीरियम में और उसको एज इलेक्ट्रोलाइट फ्यूल सेल में यूज़ किया. एंड आवर पेटेंट इज़ इन प्रोग्रेस फॉर दिस वन. तो इस तरह के रिसाइकलिंग मटेरियल काफ़ी हैं पाकिस्तान के अंदर. यानी ऑरेंज के छिलके हैं, केले के छिलके हैं, उनमें कहीं पे पोटाशियम है, कार्बोनेट है, कहीं पे कुछ है, और उनकी. तो ऑलवेज ये भी कहता हूँ कि थिंक ग्लोबली, एक्ट लोकली. हमें इंटरनेशनल रिसर्च से फ़ायदा लेना चाहिए, क्या क्या वो कर रहे हैं, और उसको हमने लोकल रिसोर्सेज की बेस पे काम करना चाहिए कि हम उसको कहाँ पे इम्प्लीमेंट कर सकते हैं. और रिसर्च करो, लॉट ऑफ कोलैबोरेशन, और یہ ایک لاسٹ میسیج ہوتا ہے فرام مائی اسٹوڈنٹ, یہ بھی ڈیولپ کیا کہ لیٹ سیو دا ورلڈ ٹوگیدر, کہ کیسے ہم مل کے کلین انرجی پہ کام کر کے اپنے انوائرمنٹ کو بھی ون گیٹ ون فری, انرجی پہ کام کریں انرجی کرائسس کو ختم کرنے کے لیے, لیکن اپنے انوائرمنٹ کو بھی پروٹیکٹ کر رہے ہیں. تھینک یو ویری مچ.
ایک تو یہ ہے کہ نینو مٹیریلز اٹس یہ سائنس یا فزکس میں پرٹیکولرلی یہ صرف نومیریکل میئرمنٹ یونٹس ہیں. اب نینو سے ہم جائیں گے فیمٹو پہ آٹو, مطلب ہے یہ کوئی ایسا نہیں ہے کہ اٹس اونلی دی میئرمنٹ وچ از امپورٹنٹ. اس کے حساب سے نینو مٹیریلس, جو مٹیریلس بیسیکلی سب نینو ٹیکنالوجی والے جانتے ہوں گے کہ بیسیکلی اگر 3 ڈیمینشنز میں اینی 2 ڈیمینشنز اگر نینو سائز ہے تو دیٹ از کالڈ نینو مٹیریل. شیٹس ہیں جو بھی ہے تو اٹ از اونلی نیم نتھنگ. اور سمارٹ بھی اسی میں نینو آ جاتے ہیں, بیسیکلی میئرمنٹس ہیں. دوسرا میں نئی ٹیکنالوجیز کا ذکر کرنا چاہتا ہوں. تھنگز آر گوئنگ آن. اب اسی میں میئرمنٹ سے اب پیکو ٹیکنالوجی از کمنگ اپ, اور اس کی سپٹمبر 2013 میں بک بھی چھپ گئی ہے, کوئی 600 پیجز کی بک ہے جس میں پیکو ٹیکنالوجی کے متعلق کچھ ایکسپیریمنٹ سجیسٹ کیے گئے اینڈ سو آن. اور پیکو سیٹلائٹس مینز اگر ڈرون جو بہت بڑا ہے ویٹ میں, تو فیو گرامس 100 گرامس کا ڈرون چل رہا ہے, وہی کام کر رہا ہے جو. تو یہ تھنگز آر گوئنگ آن ان ڈفرینٹ ڈیولپمنٹ. تو یہ سمپلی میئرمنٹ نہیں ہے, پیکو ٹیکنالوجی از کمنگ اپ ان اے بگ وے. تو اس طرح سے یہ ڈیولپمنٹ ہو رہی ہیں. نینو میڈیسن میں نئی میڈیسن, تو یہ اٹس اونلی اے میجرنگ تھنگ. اور بیسیکلی اصول جو اس کا یہی ہے کہ سرفیس ٹو والیوم ریشو دی پارٹیکل سائز پہ ڈپینڈ کرتی ہے. اسمالر دی پارٹیکل سائز تو سرفیس ٹو والیوم ریشو جو ہے وہ امپروو ہو جاتی ہے, اینڈ دی پراپرٹیز بیکم ڈفرینٹ آن دیز اسمالر یونٹس آف اسکیل. تو آئی جسٹ وانٹڈ ٹو میک دس 1 or 2 comments. بٹ ویری نائس لیکچر. اور اس میں بیٹریز میں دیر از لاٹ آف ریسرچ آن دی انکریزنگ دی ٹائم آف دی ورکنگ ٹائم آف دی بیٹریز. میں وہ ریسنٹلی چائنا میں بیجنگ میں جو اکیڈمی آف سائنسز کا انسٹیٹیوٹ ہے, ویری ویل نون سینٹر, وہاں پہ گیا تو ٹنوں وہ حساب سے وہ چھوٹی چھوٹی بیٹری پڑی ہیں ٹو انکریز دی لائف آف دی بیٹری. تو اسٹوریج آف نینو ٹیکنالوجی کمنگ اپ ان اے بگ وے انڈسٹریل ان آل ویز. تو اس پہ انڈسٹری کے ساتھ آپ اس کو کریں, اٹس ویری امپورٹنٹ. یس, تھینک یو.
ایک میرا بھی سوال ہے, وہ یہ ہے کہ آج کل جتنا فولڈیبل آ رہے ہیں نا موبائل, اس طرح بیٹری پہ بھی کام ہو رہا ہے جو فولڈیبل ہوں.
سویڈن میں یعنی اپسالا یونیورسٹی میں اس میں ایک پروفیسر ہے, اس کو یورپین کمیشن کی بہت بڑی فنڈنگ ملی. دے آر ورکنگ آن فلیکسیبل بیٹریز. تو میرے ایک کلیگ ہیں ڈاکٹر عامر رزاق, دے آر ورکنگ آن دس. ہم بھی بیٹریز پہ, ہم سالڈ اسٹیٹ بیٹریز پہ کام ہم بھی کر رہے ہیں, لیتھیم آئن بیٹری اور سوڈیم آئن بیسڈ بیٹری. اس پہ کافی سوڈیم کا, لیتھیم کی ریپلیسمنٹ سوڈیم سے کر رہے ہیں, اور سوڈیم پاکستان میں بہت زیادہ نمک بھی ہمارے پاس ہے. تو یعنی وہ فلیکسیبل بیٹریز کا ہے کام کر رہے ہیں. تو اور بھی آئی تھنک کہ نسٹ میں بھی ہیں, وہ میرے خیال میں ڈاکٹر غلام علی وہ بھی کام کر رہے ہیں جو میں جانتا ہوں. اس کے علاوہ بھی کافی ہیں, لمز میں بھی ہیں ایک بیٹری کے, وہ ڈاکٹر شعیب آئی تھنک کہ وہ کینیڈا چلے گئے ہیں شاید پوسٹ ڈاک وغیرہ کے لیے.
There are two things which I like to mention here. One is the carbon dioxide absorbers you talked about. I was in a meeting and I was talking about the environmental minister here. Recently, when we are going to net zero emission and zero emission, we bought some carbon dioxide fuel energy producer of the coal. We are using fossil fuels. And I questioned him that whether we are buying the carbon dioxide absorber with them or not. We are not buying even the carbon dioxide absorbers with the coal plants. So when you are talking about environment, this is very important. Second, I like to support your progress and your project. When you talk about wind energy, you talk about solar energies, you talk about the batteries there. And these energies are dangerous in that sense because they are using very big batteries in which they are using lithiums and other gases. So this is one of the points.
Yeah, thank you very much, sir. That's why in California, they have established hydrogen station directly based on solar system, and they have introduced the fuel cell vehicles, not directly storage in the batteries because they need a lot of batteries. Even in one of project, few years back, Navy Admiral, they invited us and we visited there in Karachi, and they show us in submarine they have a very heavy battery, and they submarine they have used in 65 war and 71 war, and the submarine almost is length is more than this auditorium, and all is full of the batteries. اس کا ویٹ جو سارا ہے وہ اسی کی بیس پہ. تو دے وانٹ ٹو ریپلیس دیٹ ون کہ وہ کس طرح اس کو یوز کیا جا سکے ڈائریکٹلی. لیکن اینی ہو مین از اے گڈ پوائنٹ. بیٹریز جو ہیں ان کو اسٹور کرنے کے لیے ان کے ساتھ جو ہائبرڈ سسٹم یا انٹیگریٹ کرنا ہے تو وہ از اے ویری ہیوی. سو دیٹس وائی آلسو ان ایز آئی مینشن ان کیلیفورنیا دے یوز ڈائریکٹلی مین پروڈکشن آف ہائیڈروجن, کہ اس کو ڈائریکٹلی جو ہے سولر جو ہے جو ایکسیس ہے اس انرجی سے وہ ہائیڈروجن بنائیں اور اس ہائیڈروجن کو ایز اے فیول پھر یوز کرتے جائیں ڈفرینٹ وہیکلز میں. 1000 وہیکلز دے آر رننگ آن دا روڈ ان کیلیفورنیا. وہ اس ہائی وے پہ انہوں نے ڈائریکٹ